So consider that this is the book, and this is the axis passing through it. This is the angular velocity omega. Now let's take 3 points. Well, before that, let me show you what am I actually speaking. So is the diary. So it is just rotating like this. It is rotating like this. The axis is passing through it like this. The axis is passing through it and it is rotating like this. Now let's take 3 points. 1, 2, not yet, 2, and here 3. Now as the body is rotating, these points will experience a centrifugal force. This point will experience centrifugal force in this direction, away from the center. It is always away from the axis. This body will experience centrifugal force in this direction, and this body will experience centrifugal force in this direction. Well, now let's let the distance be r here. The distance be this. Here distance be this, the distance from the axis, and here the distance be this. Now let's take similar points like this on the opposite side of the axis. I mean, for this point, let's take a point on this side of the axis at distance equal from this, at a distance that is equal to the distance between this point and the axis. Now the centrifugal force will be in this direction. For this similarly it will be in this direction. For this it will be in this direction. Now all these forces cancel out each other. Let me show. Like this is rotating this direction. So if I take those points 1, 2, 3, 4, take those points, then I take that force. I mean, I take this force and this force. Well, so if this is the axis of rotation, this is the axis of rotation, then the centrifugal force on this point will be in this direction, while here it will be in this direction. Now if I pull it from both sides, I see that I can't rotate it. Similarly, for this point and this point, if I pull it in opposite directions, I see that I can rotate it. Well, this is the first case. Now, let's consider that the body is tilted. I mean the book here, it is a book here, is tilted. Now the axis is not passing like this actually. Now the axis is actually passing like this. Now the body is slightly tilted. Let me show practically. Initially the body was rotating like this. Now it is on this axis. This is the axis. It is rotating like this. It is slightly tilted like this. Not like this. It is slightly tilted like this. Now in this case, now in this case, let me rotate the body. Means the axis will be passing like this. Let me rotate this. Well, now I have rotated it. Now let's take these 2 points. This point and this point. Note in this 2D surface I can't show the 3D image, but actually the distance of this point from this point is actually perpendicular to the axis. The orientation of this point on this plane is actually perpendicular to the axis, and here it is also, it is perpendicular to the axis. Now if it is perpendicular to the axis, then we know that the centrifugal force always acts away from the axis. So for this, it will act in this direction, and for this point it will act in this direction, resulting in a moment around this axis. This may be z axis, this is x axis, resulting in a moment in this axis. Let me show practically. See, I showed that it is rotating in this axis. Now I have tilted it. Now if I have tilted it, it should rotate like this. It should rotate like this. Now if it is rotating like this is the axis passing, then this point will experience a centrifugal force in this direction, this direction, this direction, this direction, and this will experience a centrifugal force in this direction. So ultimately, you have pulled this, see, it is rotating. If I pull this, see, this is rotating. Initially, when I was pulling like this, I couldn't rotate it. But now here, if I pull like this, it is rotating. As it is rotating around this axis. Originally, I have set the moment or the rotation in this axis, but slightly tilted. It is rotating like this. It is rotating like this, not like this. It is rotating like this. And that's the intermediate axis theorem. This actually is a strange rotational phenomenon that was quite unexpected in the space station. That is Dzhanibekov, I can't pronounce that. That is a very hard pronunciation. Vladimir Dzhanibekov, whatever may be the scientist name, but salute, respect to the scientist. Now all I want to say that this is not fully accurate, but quite close to accuracy. This reason, actually the centrifugal force here results in the unexpected rotation in the other axis. Thank you.